Okay. Yeah, these are all the things we did in 7.3, 7.3.1, 7.3.2. All right, the new thing in 7.4 is the Laplace transform of t to a power times a function. To figure this out, this is a derivative. It is -1 to the nth power times the nth derivative with respect to s of f of s. So it involves a derivative. And I will give you an example. Let's say we've got, let me find a problem, like number 3, where you want the Laplace transform of t times the cosine of 2t. Alrighty, you've got t multiplied times your f of t. Since this is the first power, this is going to be -1 to the first power times the first derivative with respect to s of the Laplace transform of the cosine of 2t. Alright, the Laplace transform of the cosine is s over s squared plus 4. So we need to take the derivative of this function, the first derivative. Thank goodness t is not to the 4th power, because I wouldn't want to take the 4th derivative, but we only have to take the first derivative. So it's going to be -1 times whatever this derivative is, which is the bottom, times the derivative of the top, minus the top times the derivative of the bottom, all over the denominator squared, which is negative s squared plus 4 minus 2s squared. So that looks like 4 minus s squared over s squared plus 4 squared. And when I run my negative through, it looks like it's s squared minus 4 over s squared plus 4 squared. All right, so t times a function, Laplace transform of that is a derivative. Okay. Let me see about doing another one. Yeah, this is the answer. I'm sorry. Yes, we are done. After we took the derivative, we're done. Okay, and as I said, if this is a 2 or a 3, you've got to take the second derivative and then the third derivative. You've got to do however many derivatives there are right there. Okay. Let's look at another one. Let's look at, skip number 1. Let's look at one like number 1, because you can do number 1 actually 2 ways. The Laplace transform of t times e to the negative 10t. All right, this one can be done using this derivative right here, or it can be done using this one because you have e to the at, you multiplied times f of t. So you actually got a choice on the methods that you use for something like this. It doesn't matter, you should get the same answer, but just because we're in this section, let's go ahead and use the new rule so you can see how the new one works. Again, this one would be the first derivative, so that's -1 to the first power times the first derivative of the Laplace transform of e to the negative 10t, which is 1 over s plus 10, if I'm not mistaken. And I better check. Yes. So taking the derivative of that, the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom over the denominator squared. And that's going to be positive 1. It looks like it's going to be 1 over s plus 10 squared. And again, you can do it this way, or you could do this one with the transform with a shift in it. Okay. And then I'm going to do one more before I start putting all this together. Number 8. The Laplace transform. This has got t times e to the negative 3t times the cosine of 3t. You got 3 things multiplied here. And I'm not sure which is the best way to do it, except that you can do this, again, 2 ways. You can do the shift times this, or you can do this one and take the derivative of all this. I think, when I worked it earlier today, I think that it turned out easier if I looked at it like this. All right, where I had e to the negative 3t times t cosine 3t. Now, this one, if you do it with the shift, then you're taking this and you're doing the Laplace transform of this, and then you shift this answer. Does that make sense? You take the Laplace transform of t to the cosine of 3t. You do that one, and then apply the shift to it. So the Laplace transform of this is the rule from today, which is -1. Didn't I already do the derivative of that a minute ago? No? Did I do cosine 3t or did I do something else? Cosine 2t? Well, let me just go through this for the sake of doing it. The derivative of s over s squared plus 9, so that's negative. The derivative of this is bottom times the derivative of the top minus the top times the derivative of the bottom over the denominator squared. So that's minus 2s, which gave me 9, yeah, that's 2s, I'm sorry, yeah, 2s squared, so that's 9 minus s squared over s squared plus 9 squared. When I run my negative sign through, it's s squared minus 9 over s squared plus 9 squared. That is the Laplace transform of this. With this e to the negative 3t, shifts this answer from s to s minus 3, plus 3. Sorry, plus 3. So the final answer for the whole thing is everywhere I have an s, I put s plus 3. So I have s plus 3 squared minus 9 all over s plus 3 squared plus 9, and all of that is squared. Sorry, trying to get more room up here. Okay. You could have done it that way, or you could have taken the Laplace transform of that and then done the derivative. And you still would have gotten this. Okay? Now, when we go backwards, when we do inverse Laplace transform, which is what we're going to have to do also, they don't give us a formula for this, but they refer us to the table in the back of the book. And I don't know if y'all have the hardback book, right? Okay, in the very back, table of Laplace transforms. All right, we are going to be, the ones that we're going to be doing today, all of your formulas are in here, but the ones that we're doing today, when we've gotten our denominators, we've had something squared plus something squared, and then we've had the quantity squared. So we're going to be looking over here which is the second column over for these, for our formulas, all right, to make it match. All right, so when we start doing the problems, solving equations, we're going to have to look at the table. And they just jump right to it. They don't even give you any practice problems for the inverse Laplace transform. They just say, okay, use Laplace transforms to solve these initial value problems. And then they give you something like problem number 12, which is y double prime plus y, I'll clear that up a minute, is equal to the sine of t. And your initial condition, y of 0 is 1, and y prime of 0 is negative 1. So you start off just like before. Nothing looks different about this one so far. So the Laplace transform of this side, and the Laplace transform of the sine of t. This is a double prime, so my formula, s squared y of s minus, is this one s y of 0 and then it's y prime of 0? I always get that confused when I do it in my head. Is that the right one? Plus y of s equals the Laplace transform of the sine, which is, I think that's 1 over s squared plus 1. You know, correct me if I'm wrong, because I'm not looking at my tables. All right, y of 0 is 1. Y prime is negative 1. So this gives me s squared plus 1 times y of s for this one and this one, minus s plus 1 is equal to this. Then solving for y of s, divide everything by s squared plus 1. So I have s over s squared plus 1 minus 1 over s squared plus 1 plus 1 over s squared plus 1 squared. Everybody with me? All right, the first two are just normal. These are the sine and cosine. This one, s over s squared plus 1, that's the cosine when I do my inverse Laplace transform. So y of t, s over s squared plus 1 is the cosine of t, minus 1 over s squared plus 1 is the sine of t, plus, so these two are okay. They're in our original table. All right, this one, 1 over s squared plus 1 squared. You look over there at like 22 on down in that group, and we need a single number on the top, and s squared plus 1 squared. Okay, the one that it matches is number 25. All right, look at number 25. The reason I say it matches that one is because the k is a number, okay? The other formulas have got an s's on the top, and we don't have an s on the top of ours. So we're looking at number 25. But, all right, this is 1 to the third power. We're good there. But what we need is the 2. So we're going to have to multiply 1/2 times what they have here, which is the sine of t minus t cosine of t. And this is number 25. Does that make sense? Are y'all following? All right, but now I notice that this can be combined together right here because this is the sine of t and this is the sine of t. So combine those together. That's a minus sign and a 1/2. That would be minus 1/2 sine of t minus 1/2 t cosine of t. And that is your answer. So it combined the old stuff and the new stuff. Is there a question about that one? Let me look at one more. Back to the right section. Okay, let's do number 14 because it's got a piecewise function in there, unit step function, and everything all at one time. So that sounds like fun. So 14. Okay, this is a y double prime plus y is equal to f of t. All right, now if you're looking at your f of t, it's 1. It's a piecewise function. So it's 1 plus the sine of t minus 1 times my unit step function at t minus pi over 2. This is my function. And I'm back on page 309. That was the unit step function from the other night, okay? And I've got initial conditions. Now take the Laplace transform of both sides of this. Is there any question about y'all find that and see if you have a question about that one. I still want to write the whole thing down. It's 1 plus sine t minus 1, and the step is at pi over 2. Okay, Laplace transform of both sides. I have the Laplace transform of 1 plus the Laplace transform of the sine of t minus 1, it's a unit step function, t minus pi over 2. All right, this one, s squared y of s minus sy of 0 minus y prime of 0. Again, I think that's right. Plus y of s is, where are all my formulas? Laplace transform of 1. It's 1 over s. Plus, okay, now I've got to do the Laplace transform of this with the unit step function behind it on my scratch work. My g of t function is the sine of t minus 1. I need to do the Laplace transform of g of t plus pi over 2, which is the sine of pi over 2 plus t, got that backwards, minus 1. Put this in your calculator because this will simplify. Sine of pi over 2 plus t. Here's the cosine of t. So that's going to give me the cosine of t minus 1. So when I do the Laplace transform, this is my g of t plus a. I'm doing the Laplace transform of this. Cosine of t is s over s squared plus 1 minus 1 over s, and that's e to the negative pi over 2s. Or is it positive pi over 2? Negative. Okay. Okay, everybody with me? Okay, my initial conditions, back to my book. Y of 0 is 1. Y prime of 0 is 0. So that one's gone. So I'm going to have s squared plus 1 y of s. I'm going to move my s over, is equal to s plus 1 over s plus s over s squared plus 1 minus 1 over s e to the negative pi over 2s.
Did you lose?
Did I lose something?
One? Wasn't S of y
1 over s. That was the 1 over s.
Wait a second.
Which one?
When we did s squared y of s minus s y 0, wasn't y 0 1? Or did you already use it?
Y of 0 was 1. Isn't that one? Isn't this one y prime? Or have I got my formula wrong? This is y prime. That was 0. This is 1, but it's 1 times s.
Oh, so you moved it over.
So I moved it over. I'm sorry. Yeah, I moved it over. Okay, do I have everything else I'm supposed to have? Okay, assuming I've got everything I need, now divide everything by s squared plus 1. So y of s is s over s squared plus 1 over s times s squared plus 1 plus s over s squared plus 1 squared minus 1 over s times s squared plus 1, and all that is e to the negative pi over 2s. Okay, I would put all of this in my calculator and get one fraction, expand this part. Put them together, add them together in your calculator and expand it to see if it'll simplify. I know I could do this one, but this one is going to be a partial fraction right here. So just do the whole thing. And you can just type it in expand and type in everything. And all that simplified to 1 over s. Did y'all get that? That is very nice. That's 1 over s. Now I wonder if something like that will happen in the second group. I would actually put this second group in there too. All right, this one, I've got s over s squared plus 1 plus s over s squared plus 1 squared minus 1 over s e to the negative pi over 2s. Did y'all get the same thing I got? You just following me blindly. Tori, did you get the same thing I did? Right here. Okay. Okay. All right, then you can trust us today. Okay. All right, now we've got to do inverse Laplace transform of all this. So inverse Laplace transform to get our y of t, and I'm obviously going to have some scratch paper. 1 over s, that's just going to be a 1, plus. All right, the rest of this stuff, when you do inverse Laplace transform, this is your shift, right? Your unit step function. So you know you're going to have u to the t minus pi over 2. And all of this stuff in here is shifted by this. So when you do that, all right, let me get my little formulas out of here. Inverse Laplace transform. I need to do more scratch work. All right, for s over s squared plus 1, that is f of t is the cosine of t, if I'm not mistaken. But I need f of t minus pi over 2. I've got to shift it back. So that is the cosine of t minus pi over 2. So put that in your calculator. It will probably simplify. Simplifies to the sine of t. So far that one is the sine of t plus. Ooh, I'm going to save that one till last. I'm skipping down here to the minus 1 over s. Because the 1 over s, that is just 1. Plus, now I'm going to do the s. I'm doing the inverse Laplace transform of the s over s squared plus 1 squared. This one you've got to go to your table, find which formula it's going to be. Too much going on over here. So I need an s to the first power on the top, and I need s squared plus k squared. Yes, number 22. All right, what am I missing from there? I'm missing the 2 from the top, right? So I'm going to have 1/2 t sine of t. But this is your f of t. You've got to shift this also, so I need f of t minus pi over 2. So that is 1/2 t minus pi over 2 times the sine of t minus pi over 2. And this probably right here is probably going to simplify also. Sine t minus pi over 2 simplifies to negative cosine. So this is negative 1/2 t minus pi over 2 times the cosine of t. So back up here, this is minus 1/2 t minus pi over 2 cosine of t, and all of that has the unit step function behind it. And there is my answer. So problems like this kind of put it all back there together. Okay. That is what you need to know out of 7.4. So do I need to do another one? Do I need to do something else? Do what? You don't want to write down another problem? Oh my goodness. I think I'm going to try that.